level of classes. So thus far, we've been operating with sort of methods defined in isolation of classes. We've been operating with functions defined explicitly as values, and all that is well and good. But Scala is a mixed paradigm programming language, meaning it supports object-oriented program very well, extremely well, arguably rather better than does Java, C#, or any number of other languages. But at the same time, it also supports functional programming. And we've been focusing on the functional programming side. Today we're going to see classes, and you're going to be using classes for future assignments and take-home exercises. So, Scala adheres as a general philosophy to a number of principles. And one of these principles, ladies and gentlemen, is in fact the idea of minimalist syntax. And you're going to see how that comes out within the context of classes momentarily. Okay, so a class declaration in Scala is a construct that's particularly abbreviated from the perspective of someone who's coming from the Java world, C++ world, C# world, Objective-C world. So here we have a definition of a class, but you'll notice that next to the class, you actually provide some information. Okay, next to this, the name of the class, you're actually providing what might at first be very puzzling set of things: age, income, and for example, mother. So we're defining a person, and here we're saying, okay, we want age to be a field that's not just naming a value that's going to be unchanging, but it's in fact indicative of a field that can be changed, can be set and gotten, if I could misuse English, obtained via get. Similarly for income, whereas mother is a field that never changes. Once you have a mother, that's always your mother. So ladies and gentlemen, here we have person, but we're also defining the fields associated with person and their status as far as whether we can get and set them. And this, in fact, is defining the parameters that we present for the constructor. Okay? So when we create a new instance of the class, unless we define additional constructors, which then delegate to this one, we're going to specify the age, the income, and the mother, and it'll create our person. Okay? If we want to define additional constructors, we use this. Okay? So here's an example, that example there, and we could say that the primary constructor is written like this: age, income, and person. Okay. The constructor, moreover, executes all code that's declared directly in the class. So if you have code inside the class, inside the curly brackets, that is not within a method, that code will be executed when the constructor runs. And then there may be auxiliary constructors that take a subset of arguments, for example, and fill in default values for the others that can be delegated. Okay. So let's try this, right? Let's go and try this, and we can take a look at our handiwork. So I'm going to go over to my handy Scala window here, and I'm going to scroll up. Okay, so here we go. Class. Let's do this class. Let's do the first one we did. So class person, and you're going to need curly bracket begin and end after that. You're going to want that. Okay, so let's call it class person A. We're going to be defining a number of person classes. Okay, so here we go. Person A, and we're going to take an age, an income, and a mother. And here we're not specifying whether they are vars or vals, and so they are by default. Anyone? What is more beautiful? Sorry? Vals. Ladies and gentlemen, for reasons we'll talk about after the break, value objects that don't change, are just much easier things to reason about, to build things out of, to optimize, to share than classes which can be modified over time. That's not to say you shouldn't use a class where is things that evolve over time. There are reasons for doing that. But by default, Scala, hewing to principles of functional programming, prefers classes. By default, it yields to classes that if you don't specify it, it's a val. Okay? So here we go. We're going to have age as a double, income as a double, and mother as a person. Okay? Here we go. And this will be person A. Okay, so we're going to say age as a double, income as a double, and person A, mother being person A. There we go. Okay? Hey, don't give me that. There we go. Okay, I forgot my things. We're going to be expanding this later, but that's fine. Okay, ladies and gentlemen, this has created a class, okay? And if we want to, we could say val, P1 equals new person A, right? And we could say we'll give an age and we'll give an income. And as far as the mother is concerned, well, we'll give a null for now, okay? Value income, sorry. What am I doing? I've got to fill in values, sorry. 35, income, 35,000, and null. Here we go. Here's a person A, okay? There's an instance of person A. We have created a new person. And this is syntax that should be familiar with anyone who's used C#, C++, Java. We knew it, right? We knew it. Both in the NEW sense and the KNEW sense. Right? Yeah, familiar territory. Okay, let's take a look at something though. This is a pretty nifty feature. Can you see this? Yeah. Okay. Java P minus private person A. Here, ladies and gentlemen, we're going to see what's inside of this class from the perspective of expressing it in Java. What does this person A class have associated with it? Well, it takes in a double, and person A as its constructor, and that's what's associated with it right now. We don't have anything else. Let's if we want to access these things, it turns out they're going to be final. We can also look at just the public things here, which it turns out here will be, I believe, exactly the same. Yeah, these are sort of the public interface. It just includes these two things. So we can actually ask, what does this turn into behind the scenes? We're going to be using that a fair bit during this lecture. So we can define auxiliary constructors, which basically take in other arguments and they delegate to our main ones. So for example, here we have a person taking those arguments, and then we have an auxiliary constructor which just takes in whether or not this is female, and if so, it delegates with sort of default values for age and income. Okay, assuming that we have a newborn, etc. Okay, now one of the features of this is that there's implicit fields that can be created, and it turns out that not all of the things listed in the class headers are declared as fields. They may only be used in passing during the constructor, but we can request that certain of those things we passed will be a field by using val and var explicitly, okay? And if there's a parameter that's used in another method, then we'll need it as a field. It's not merely used in the constructor. And which sort of field is created depends on whether we declare a val or a var. So let's try this, okay? So let's go back to our Scala shell here. Here we go. And we're going to create person B. And let us, ladies and gentlemen, here go and This time, we're going to change this to be person B. And further, we're going to say this is a var, this is a var, and this is a val. Okay? There we go. But more than that, we're going to use these things here. And I'm going to put in place a method that's going to be called, print, report, something like that. And this report is going to basically itself print something out. Okay, so here I'll show you the code for it. Give me a second here. So we're going to have it report with, okay, it's a case, here it is. Println, we're just going to do this println thing. So we're going to print out the age, the income, and the mother's value. You note this $sign. Scala supports string substitution. So rather than having to do the whole printf thing or what have you, we could simply use an s in front of the string and then put a $sign, and that will print out the variable with that name. Okay. So let's do that, okay? So we're going to println of this thing so that we print these things out. And the point is that we're going to use them somewhere, okay? Println, and we'll do age being age, income being income, and mother being, and it's going to just render it in a very simple way. Okay, and now we have to close that. Sorry. Boom. Okay, we have to close the quote and close the call to println. Okay, here's person B. So now we actually have a method within person B, something we can do with instances of this. Just like before, we could go and allocate it. Here's P2. That's someone of person B, right? There we go. Let's go take a look at person B here. Okay. The fox has shown its tail. Okay. Here, ladies and gentlemen, and I'll scroll up here in case some of you are waiting to enter this. So we did class person B. These two were variables. That one was a value, meaning once we have a mother, which person is our mother never changes. What our age is changes over time. The value associated with age changes over time. The value associated with income changes over time. But we're always referring to the same mother. Okay? So here we've referred to these, and as a result, it's gone and actually created methods behind the scenes for them. What are these methods that just say age, begin paren, end paren, income, begin paren, end paren, mother, begin paren, end paren? What are those? Yeah, those are just getters. Those are things that get the value. Okay? And in Scala, every field has getters and setters. Okay? Every field is going to have it's going to be, so regardless of whether it's maintained internally as a calculation or as a internal, actually a field that remembers that value as a piece of data, you're going to access it through a getter. And what are these things, age underbar equals or income underbar equals, what we don't have for mother? Those are setters. Okay, those are setters. Those are the things they handle a case where we're setting a person's age to be equal to something. And that too is occurring through a call here. Okay? So this is the public interface for person. And if we look at the private interface for person here, let's go look at private. Here we see something else. What else is added on? Yeah, these are the fields themselves. Why is person B's mother final?
Can't change.
Yeah, the reference can't change. We're always referring to the same mother. That's not to say that And mother can't herself, her income can't change, her age can change. It can change characteristics, but we're always referring to the same one, the same mother, okay? But meanwhile, age and income are not final because they can change over time, okay? So sometimes it's quite useful to use this Java P construct to allow us to put these, to see what's going on. All right. So because income is a change in quantity, we can ask, we can see that we can set it and we can get it. Now in Scala, the syntax for doing that is pretty straightforward. So you remember that just a moment ago we created a person B here, and so if I want to go access that, I could say person B dot age equals 100, right? What's going on here? What's going on here? Is it directly setting the age field like it looks? No. What's it actually doing secretly? It's calling age underbar equals. This is in accordance with a principle. I think it was Bertrand Meyer that stated it. It said basically the users of a class, they shouldn't know whether or not things are stored as data items secretly in a field or whether it's a calculation, whether some data structure is being updated more generally versus we have an actual field that just holds that item. They shouldn't have to care about that. And the syntax shouldn't change. You shouldn't break code if you change from a situation where it's actually stored in a field to where it's looked up in a table or something. We should allow for changing the implementation without changing the interface, how people use it, so that when we evolve the implementation, it doesn't break other people's code. Okay? That's a principle of uniform access to these things. And in fact, Scala supports that. You'll notice here we're assigning to it, and it looks like we're writing directly to the fields, but secretly we're accessing this. And similarly, we can go and we can say p2.age, and we can report it, but here we're actually calling age. Okay? It's taking care of turning that into, desugaring it into those calls. But from what we get, it's a nice clean syntax. Okay? Okay. Classes, ladies and gentlemen. There's lots of other components of this. Default values I could talk about, work with private accessors. But our goal today is bigger than this. Yes, I want you to know about classes. Classes in Scala are nice, and classes in Scala include this ability to define methods like we've been doing. So here we've got one method, and we can go and we can say p2 dot, and I wonder what would happen. It might have a conniption with the mother. What should we have done instead of none? Instead of null? What should I have done? I did something very bad. And if you were to hit me with wet noodle, I wouldn't object. What is it? What have I done bad?
You should use an option.
Yeah, I should really use an option. I mean, my gosh, here I am going on about monads, and you let me just pass in a null. Ladies and gentlemen, the person who invented null, there's a person and they're living who invented null. And surprisingly, they don't have a security detail following them around to protect them. They say that null is the $1 billion mistake they declared. They made a $1 billion mistake by introducing null into the world. It's opened a Pandora's box of crashes. And the wrath of millions of programmers might be placed upon them. But we have much better ways than null for dealing with things with monads. And we should use an option of a person, and if we don't have the value, it could be none, and we can handle it in a nice way. Instead of just having a null, and then we try to access it to print it out and ba-boom. But let's, do you feel lucky? Okay, here we go. Okay, oh my gosh, what did I forget? I forgot the S. Okay, yeah, here we go. Okay, so reprieved, here we go. Hey, what? What am I forgetting here? That is most odd. Hello? Yes, of course. Of course. Thank you. Yes, there we go. So P2 was still referred to the old class, the instance of the old class. Good call. Good call. Okay. So, ladies and gentlemen, fortunately, it knows how to print null. The $1 billion mistake wasn't $1,000,000,001. Okay. So anyway, here we have a nice thing, and we see the variable substitution supported by this S. Scala has several types of strings. It has substitution strings. It has raw strings, which are written with raw in front, or with triple quotes on each side. And there it basically says, hey, if there's a backslash in here, don't try to interpret it. Just treat it as a backslash. And those strings are, and then it has regular strings, which don't do substitution, and where a backslash n turns into a new line character, for example. Backslash t into a tab, etc. So several different types of strings. This is a nice one. And it's not simply a variable name you can put here. By putting curly brackets around here, you can have an arbitrary expression, and it will print it out. It'll actually print it out. So, you could report lifetime earnings, age times income, or something like that. Okay. Anyway, our goal today, though, is much bigger than classes. Scala classes are great. They allow for terse syntax. They have nice features of uniform access. They in fact, will allow us to, as we'll see, achieve a sort of multiple inheritance without the risks of multiple inheritance. But all that's after the break. Today, ladies and gentlemen, I have an urgent need. I want you to know about classes because you're going to be using classes soon enough. You're going to put, don't all drop now, but you're gonna recast Conway's Game of Life in Scala using a class around it, okay? And you want to know about class syntax here, okay? But right now we're going to be going on to a different sort of classes. A type of class that's beautiful, and a type of class that's powerful. A type of class that's going to have extra features, it's going to be immutable, and it's going to be used in pattern matching as one of its big goals. And this is going to be called a case class. A case class, okay? But before I do that, just thinking of the didactics of this, I actually want to introduce something that I have a few slides later, and I'm gonna circle back. So, ladies and gentlemen, in Scala we have classes, and informally we'll call instance of those classes objects. Those are objects. But beyond that, in Scala, what we have is the ability to declare a special type of object. And this special type of object is called a companion object. It's a companion object often for a class. And this provides support for what are called singletons. Now, in your classes in 370, Orly, did you talk about singletons? Where would you use singletons? What do you use, for what purpose are singletons meant?
Basically, you want only one particular class in the program.
Yeah, you want a single place where information is maintained that's not different for each instance of the class, but it rather relates to the class as a whole, right? So maybe you want to count the number of times that class, the number of instances that have been allocated for that class, for example, over time. That's not something that each instance is going to maintain, because it's not information about an instance. It's information about the class, right? It's information how many times that class has been allocated. So we want one variable associated with the class as a whole, right? How do we do this in Java? Yeah, we use a static method. Now, ladies and gentlemen, I circulate between many domains. And sometimes given terms, particular acronyms, have very different meanings in different domains. I talked about how in some of the classes I teach, I'll go from talking about system trouble incidents within a morning lecture as STIs, and then I'll talk about gonorrhea and chlamydia as sexually transmitted infections in the afternoon, also known as STIs. That same term can mean multiple things. But one term, it's a travesty, in my view, that it's an issue almost up with which I will not put, is this issue that we call things static when they're about the class. Really, static is used in contraposition to dynamic, properly used. It's not changing. But a static quantity in Java can change. It just means it's associated with the class. And unfortunately, we're burdened with that name that it's a static field. But that's what it means. It means it's associated with the whole class. And Scala, to its great credit, did away with that. It swept it away, that ugliness. And it declared that all things that would be handled as singletons, you're keeping track of information kind of about the class in one place. Instead of declaring them classes, you declare a companion object, okay? And this companion object is declared with an object. It's declared as an object C, and I'll show you them. Here's an object. Conway's Game of Life. Yeah, you can use this code, okay? Soon enough. Object, Conway's Game of Life, extends app. So this is almost what your code will begin with when you're implementing Conway's Game of Life. We're going to have a class called Conway's Game of Life, but there's going to be a companion class called Conway's Game of Life that is going to keep track of the sort of designated single instance of the class of Conway's Game of Life. And it turns out that that's how you want to do things within the framework of kind of running Scala code within a module in this case. So this extends app, which is kind of like saying it provides main. You know, we have main provided in Java as the designated place where things start. This is the designated place where code starts within Scala. So for the whole program. So we're going to have object this, and this is going to be a single place, and it has the same name. See, it has the same name as this. Or here we're going to declare an object compute liveness rule. There's only going to be one of them at a given time, one instance of it at a given time. So it's a singleton. There's only a need for creating one instance of this rule. Okay, and we'll be seeing that later as well. We're going to come back to companion objects because they accompany case classes automatically. They are created automatically in the instance of case classes. Okay, so case class, ladies and gentlemen. A case class is going to be written in a way that's very similar to what we've seen for classes, but it's going to have additional semantics and one additional keyword. So here we're going to go, and we are going to create a case class. Okay, let's go back to our class. We're going to say case class. Okay? A case class is different from a general class. One way in which it's different is that everything, ladies and gentlemen, is read-only. So we actually can, if we want, I believe we should be able to simply leave these things out, okay? And this is going to be called person C, okay? Here we go. Case class is read-only. Case class is a value object, which is considered a kind of best practice if you can do it in your area. Here's person C. This is a case class.
Is there a reason why you didn't change the mother vowel?
I did. Person C.
No, but the vowel before the mother?
Yeah, I could have to be consistent. So here we go. Thank you. There we go. And basically everything is vowel. Everything is vowel here. It's all vowel. Okay? That's one aspect of a case class. But we're going to see there's more. There's a lot more. And case classes will open the door for some beautiful programming when we can make use of them. Okay, so let's go see what's behind it. How do I see what's behind this? I taught you a way earlier, and I'd like you to repeat it to me. Yeah, Java P. And let's go first look at the public features of this. Person C. Oh my gosh. Oh my gosh. Just look at the public things. We see a lot of things. What things are familiar here? What are these top couple things? Yeah, so these are the getters, right? Notice there's no setters. Here's report. This is for our reporting method. Then we have the ability automatically to do some copying of it. There's some additional components that I won't get into that have to do with iterating through it and so on, and that testing equality of this. We further are going to have a very interesting feature associated with this that's not obvious here. So we can, by the way, we can go look at private, and here we will see additional items such as these final. You see they're all final? What does that mean?
They don't change.
Yeah, they don't change. They're read-only. They're immutable. This is an immutable instance of a class. Let's go look at something else, though. Here we go. Let's go look at the companion object for this. Ladies and gentlemen, there's a companion object associated with this, just like I introduced objects. And this companion object has some further features that will be critical for our use of these classes. The companion object has certain functionality that will carry over to how we use the classes, okay? It's appearing kind of behind the scenes to make some things really sweet. When I was young, they called it slick. Do they still use slick? Okay, well, it'll come around in another couple decades. Okay, so ladies and gentlemen, apply and unapply are going to be key. Let me tell you what apply is going to do. Well, why say it when I can do it? Here we go. Ladies and gentlemen, here's our public C. And how did I allocate an instance of this? I said val p3 here. And what did I do? Yeah, I could do this, person C, and I can do their age is, 55, their income is 10,000, and I could say their mother is null. Okay, here we go. I could still do that, but what's better now is because I have an apply in the companion class, I could just do this. I don't actually have to do new. I could just say, create this. Where have we seen this before? We've seen it many times.
Vector creation.
Vector creation, array creation, sequence creation. Remember this?
Vector 1, 2, 3.
Okay. Some of the most important numbers around, or their approximations. So this is an example of a companion class. A companion class is taking care of apply. Why do we call it apply? Because we're applying the companion class, in other words, calling it here, to some data items. And that's going to return an instance of the class. Okay? So this is an example of application of a companion object. And it allows us to easily create an instance of class without this whole new thing. Sometimes the number of news just get, troublesome and it's very wordy. We could do it much slicker through this. But what comes more powerfully is something that's going to initially go unnoticed for the next few minutes, but we're going to return to it in a big way. And that, ladies and gentlemen, is this. Unapply. I'm going to come back to it, but with a nod towards spiral learning, I'll just say applies job and life. If you consider the companion class, applies job and life is to take the elements that are going to define the class, make it up, the case class, and turn them into an instance of the case class. Do you see that? It's turned into an instance of the case class. Facilitated by the companion object determined. So the companion object took care of taking these values that make up the case class and giving us the value of the case class. Unapply is going to do the reverse of that. It's going to do the inverse of that. So it's going to take what? An instance of the case class and turn it into the pieces that make it up. It's going to take it apart. It's going to destructure it. And it's going to do it in a way that is awesome. Just you wait and see. My words will be borne out. Okay, so ladies and gentlemen, case classes are generally immutable. They contain a value field for each parameter, and they contain a lot of other sort of nice functionality that's automatically provided to us. But most importantly, we can use here apply and unapply. It turns out that there's also this tupled method that basically if you have a tuple, which is that thing that's written in parens like this. If I have a tuple of three things here, age, income, and mother, I can then apply the companion class to that tuple and use it to create an instance of the class, not just to separate values created by my parameters. And it turns out by comma separated values here. Turns out that would be a nice feature in some contexts. It just makes it extra slick, the notation. Okay, here we can go and we can apply instances. Now, by the way, the apply operator, the apply method is a general thing in Scala. We can actually put applies not only in companion classes to allow us to say a vector of this or person C of that to create an instance. Turns out we can actually put it in instances as well. If we put apply in the case class itself, not just in the companion object of the case class, in which case you can call, it's as if you can call an instance of the class as if it's a method. I'm not going to go into that, but it's a sweet thing, okay? So not only can you have a companion object that supports apply, you use the name of the companion object here, you can have an instance of the case class and apply that as if it's a function and have it operate on things, which is slick. So you might have an FFT function. Okay, now time is running short. Let me introduce. I'm going to do this without going into all the how it works. If time allows, at the end of the lecture, I'll talk a little bit how it works. Let's talk about unapply. So apply takes the pieces that are going to make up the class and creates an instance of the class for the companion object. Unapply is going to take an instance of the class and it's going to take it apart and give us the pieces back. Okay? It's going to be used in many contexts. Some of them are shown here. Let us do one of these on the command line. Ladies and gentlemen, val. Val, person C, age, income, mother, equals P3. Here's the age from it. Here's the income from it. And I could do the same for mother. I don't want it to scroll off. Here, this is where unapply is being used. Now, this is going to seem particularly puzzling. But basically what's happening is it's calling the companion class's unapply method on P3 and binding the return values from that to age, to income, and to mother. And we are in this one line, we are declaring a value called age that's bound to the age part of this, a value called income that's bound to the income part of this, and a value mother that's bound to the mother part. So we're destructuring this value. We're taking apart this value into its constituent components and giving them each names that we can then use in our code. Nifty. We can do this with, in fact, lots of cases that are pretty neat. For example, I'm not going to go give an instance of this, but I could do AB equals my function, you know, da 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 da, and this will take apart a tuple that's returned, and it will bind A to the first element of the tuple, B to the next element. Maybe it's a tuple of index and name, a string. So the first is an int, the second is a string, and it will take it apart and bind it to A and B. Okay, that's just another sort of variant of this thing. So this is where unapply is being called. A common case where basically we want to grab the features associated with an object, an instance here, and we want to be able to manipulate them easily in our code, rather than asking for p3.age, p3.income, p3.mother. We just write it like this. Case classes give that automatically. Because we declare it's a case class, we can do this. But that's just the beginning of the fun. Okay? What our focus is going to be for the next 20 minutes is that we're going to use this unapply operator in what are called pattern matching. And you see two instances of it here, but we're going to go to a much broader set of them in a moment. And here, we are going to have the ability to take apart an object and see which of several matches apply with it, at the same time binding arguments, associated binding elements that we can then, if it matches an array, with the first element and the second element, we could use X and Y in our code. If it is something which matches a certain regular expression pattern, we can get from that the day, month, and year and use that in our code. Because the regular expression is matched a string which contained a day, a month, and a year. Or if we have a loop, in fact. This is not pattern matching per se, but it's kind of similar. We have a loop. We can loop over each individual in the population, extracting the age, income, and name for each of them, and handle that in the loop body. Okay. But let's go to this pattern matching. So this is made possible via the companion objects associated with the case class. And I'll come back to some specific understanding of this. Okay, so what I'm going to do now is to transition out of this to our third element here, which is matches, okay? And I think I will, because this is a natural transition, I'm going to save this.